Let's take a look at some beautiful symmetry and see if we can classify it. Let's start off by taking a look at some beautiful frieze patterns and see if we can actually classify what we see. So here's a sort of ancient one that we might imagine. And I want to identify the kind of symmetry that we see here. Well, it's clear that this is just translational symmetry, because if I just take this entire thing, and you have to imagine it now continuing forever, and if I just slide it over by one ox, the pattern would look identical. So this has translational symmetry. Now, to illustrate with another example, let's take a look at this really attractive pattern. Again, imagine it goes on forever. Well, of course, this has translational symmetry. You can see that this peak and this peak and this peak are all the same, and these low points are the same. If I were to shift it over one peak, it would be the same. But actually, this has something that's even more interesting. This has what's called glide reflection symmetry. What's that? Glide reflection symmetry means that I can slide it over a little bit and then reflect it. And check it out. If I just slide over this point to here, but then do a reflection, look what happens. This down point would be here, and then when I reflect it, it comes on top. And this T would be shifted to here, T, but then when I reflected it, it would be an upside down T. So this actually has this special glide reflection symmetry where I shift it just a little bit and now reflect, and I actually get it. Does this have a glide reflection? No, because you can see there's no sort of reflective properties that these ox have. But if I turn an ox on its side, upside down, it would look like an upside down ox, not a right side up ox.